So some common screens you might hear: HD screening, okay? Samba dot or Samba dot, that is like that hybrid screening where we've got the, sometimes it's just the Samba dot is just where you've got it just in the highlight area, or sometimes it's where you're doing it in the highlight and the shadow with the traditional AM screening in between. Just a kind of like almost like a brand name for ESCO of that type of screening. We talk about flexo dot, okay, and that's primarily thinking of round dots versus elliptical dots like we use for offset lithography. And then square spot, so sometimes we choose some of these, okay? But there are different ways of controlling the size and shape of ink film thickness. Okay, so we're back to what we talked about on Tuesday of just putting ink on paper and how are we controlling that, and how are we controlling that ink film thickness and what we put down. So further lectures will be talking about analog rolls, and we'll also be looking at analyzing some test images and what the inputs were on those and making some comparisons. And we'll introduce the use of the virtual OMIT press that we have at the Sunoco Institute, introduce you to some things on that where you can see what happens when you change some of the inputs. So you'll get a chance to run the virtual press and be able to change things like impression, be able to change things like the analog roll volume that's in there, or the inks and things like that. So you will get some realistic kind of feel for how presses work and what changing some of those inputs do to your images. So what we're going to be really trying to achieve by doing some analyzing of these test images is looking and seeing what happens to these tones. So when we're reproducing this image, and we'd like to see, you know, if we put a 30% in, we'd like to see a 30% print on the end. But realistically, what happens is we get all this dot gain, and specifically in Flexo, a lot of times that highlight is not existent. You know, a lot of times that if we can hold a 1 or 2% dot on our plate, that dot will gain to a 12% on a narrow press. If we're talking about an analog roll that holds takes on a lot of ink or delivers a lot of ink to the plate, we could have a 2% dot that prints as like an 18% dot. So if we're talking about something that automatically is already darker and we have to carry a dot there, because even in the highlights of this image, we have details there. You can't just print a white spot there and expect that you're going to carry any details. So we have to print dots, and if they're already growing a lot, we have to do something to compensate for that, to try and keep this tonal range broader, wider, and longer like the original. So if we start shutting down and we print such a dark highlight, we've got a lot of tonal or tone compression happening here. Okay, the tones get closer together, like here in the highlight end of this where the dots have grown, between 5 and 10%, there's not much difference there. You're not seeing much difference at all. So when you see that happening in your image, you start losing a lot of the details and a lot of the definitions in your highlight areas. So we're going to have to do corrections to our images in prepress to allow for this, regardless of what kind of screening we choose, what LPI we choose. We still have to account for this. And this is something that we have to find out from each one of our different case scenarios of, you know, what press we're using, what substrate we're using, what type of plate we're using, what kind of sticky back we're using, what analog rolls are in the press, what inks we're using, what the viscosity, pH, all these things will impact what happens to our input. So if in our electronic file input, we have these tones from the original coming into the file and then ending up on our plate, okay? And then we go into that and then print it, okay? And we get something like this. What exactly is happening? Okay, well, we get a tone curve where the dots that we put in, say that 50% dot there, you know, we may have thought it was only going to gain to say 65%. And in reality, what ends up happening, okay, And if we don't run tests, or we think we're just going to apply some standard flexo curve that doesn't exist, or apply offset gain curve, dot compensation or gain compensations or profiles, it's not going to work. We're going to end up with this image that looks much darker. So if I really want that right size dot, I have to find out what this curve is, okay? What my tone reproduction curve actually ends up being. Okay? So I print this whole scale of dots of 5, 1. Sometimes you'll have a tone curve, a grayscale over here that's going 1, 2, 3, 4, 5, and then it goes up by 10, 20, 30. So you might actually see a different tone scale than this. Is, for instance, for different flexo processes, or flexo versus screen printing or offset, because you're trying to do so much to control that highlight dot and to see if you actually can hold it on your plate, see what happens when it actually delivers on the press, and then be able to come back and make the compensation necessary. So if I wanted to fix this file so that it looked more like this one I printed, I'm going to have to change my 50%. Okay? So I'd have to come in here and figure out, where does my 50% actually intersect this tone gain, or this curve where it gained to, and I'm going to have to make that compensation back to this size dot. And that's going to cause me to compress every tone from this point down to 0, or wherever my minimum dot is. I'm going to be compressing those tones closer and closer together. So there's a certain amount of tonal compression you're not going to be able to overcome. Okay? You're going to have to deal with that. And that's where, when we look at LPI of our screens that we choose, that's going to make a huge difference. That you might think, oh, well, I'm going to print 150 LPI on everything because that's really fine. I'm not going to be able to see the dots, and I'm going to see the rosette pattern. Well, the simple fact is, given other inputs like how soft your plate is, or how much impression you apply, and how smooth the surface is that you're printing on, how much ink is being picked up from your analog scroll, you might get so much dot gain happening from that with those finer line screens that you get way more tone compression, and your image will look worse than if you had just used, say, 133 LPI or 120 LPI or even 100 LPI. So tonal compression is going to become greater, and dot gain is going to be greater and more significant on these highlight dots as you go up in line screen, because those dots, remember again, as you go from a lower line screen to higher line screen, a 1% dot that has a little bit of gain on it is going to be much more significant to that finer dot. Okay. So if we've got excessive dot gain going on with 4 colors, imagine the unexpected results we get if we haven't gone in and adjusted those tone curves for each one of those colors. We're going to get significant gain. So now you've got all 4 colors on top of each other. And then you also have the problem with, say, if you look at the top of this Volkswagen camper van, if you look at the top here that's supposed to be white, you then start seeing some problems where colors start shifting. One color gains more than the other, then maybe you start seeing some color shifts in here as well, not just an overall darkening of the image. So when we look at something like this happening with all 4 colors, we're talking about every one of those colors is gaining on top, on top, on top, on top of each other. So it becomes really significant. So at this point, you've not only got one color, but you got all 4 colors, and do they all gain the same? So it becomes imperative that you know and keep track of all your inputs. So if you go into characterizing a press or analyzing a press target, you've got to know what analogs you had in there, what inks you were using, what kind of plate material you were using, what screens you were using. Everything you need to keep consistent, because if I do all this work and I create these compensation curves or create color profiles to compensate for these this dot gain, I'm going to run into some huge problems if I don't install or put the same analog scrolls in the press, or I don't control the viscosity of or drying rate or trapping of my inks, if I don't control and utilize the same sticky back for mounting my plates, if I don't utilize the same plate material, or I completely forget to apply the proper screens and proper screen angles and proper compensation to my files in pre-press, I'm never going to get the same results twice. So once we run these tests, we don't run them with images like this and see what happens. We're actually going to use test images. And you're going to work through and creating your own test images so that you see how that is built and what you do to those. So summary today, why do we do halftones? Because we have to take a binary process and make it where we can print those different shades. We went through some of the different screen rulings and why we have those, and talking about what happens because of dot gain as far as tonal compression and it being more significant on finer line screens and smaller dots and then also talking about screen angles and our choice of those. Okay? And then we have to measure everything. So when we get into looking at some of our test targets and some of that analysis, we'll be showing you some actual demonstrations of utilizing some of those tools as far as measuring with spectra or color spectrophotometers or color emitters to getting true data out of that as far as the actual colors reproduced versus also the dot values produced and so forth.